What if you entered the quantum realm? Living in the quantum realm is rare and appears to be impossible. Everything you thought you knew about existence has been put into question at the subatomic level, and previously unthinkable phenomena are suddenly feasible. In this video, we will look at quantum theory, quantum entanglement, and quantum mechanics to completely understand what is going on. We first need to think about light in order to comprehend the broader strangeness of quantum mechanics. Light has long confounded scientists, who couldn't determine if it was composed of waves or particles. Many others have attempted to demonstrate that light has wave-like features, but Isaac Newton was one of the first to assert that light is composed of particles. Up until Albert Einstein eventually put an end to the debate by demonstrating that light was both a wave spreading in all directions and a particle moving in one direction in the early 1900s. Quanta, or what we now call photons, were the little energy pockets used to measure that light. But from there, everything only got stranger. Although Einstein himself is said to have been suspicious of the idea, these new schools of thinking gave rise to quantum mechanics, which analyses subatomic particles. Because he thought the world ought to be objective, somewhat predictable, and observable, Einstein had a problem with the quantum theory. The quantum world, however, is replete of bizarre events that seem to have no place in science at all when we zoom in on them. The known principles of regular, classical mechanics, as well as all of our preconceived assumptions of what is real and feasible, disintegrate at this point. Everything in quantum mechanics operates as though amid a constant what-if, imaginary cloud of probabilities. Particles simultaneously rotate in two directions. Like a ghost, matter can pass through solid barriers. When two particles interact, their fates become intertwined. Even if they ended themselves on different ends of the universe, they could conceivably still communicate quickly. Even temperatures exhibit a variety of behaviors, leaving frigid areas where heat should be present according to traditional thermodynamics. You would need to be exceedingly little to enter such a facility, that much is certain. When something is at its tiniest size, scientists define it as being quantum. Distances in the quantum realm often measure less than 100 nanometers, with a nanometer being 1/1000th of a meter. Beyond that, it's virtually hard to foresee how the quantum realm will actually appear. All objects lose their sense of shape at this scale. You would be surrounded by hazy, blobby atoms and particles and would be drifting across seemingly empty, impossibly large spaces. In some respects, it would feel as though you had been abandoned in a very strange region of space. Importantly, the particles that do cross your path appear to come and go quickly. They would only become solid when you stared at them, and anytime you turned your head away, they would only be a shadow in the corner of your eye. In this way, quantum physics appears to change the link between matter and people, feeding into philosophical discussion. Erwin Schrodinger is best known for his thought experiment on quantum theory known as Schrodinger's cat. It makes the assumption that a cat is enclosed in a container containing a vial of poison that will randomly release at any time and kill the cat when it happens. We can't see whether the poison has been released yet from where we are outside the box, thus we are unable to determine the cat's outcome. However, according to quantum mechanics, the cat is both alive and dead, just as a quantum particle is both real and unreal, and we won't know for sure whether this is the case until we open the box and look inside. The double-slit experiment demonstrated a similar finding with light itself in another investigation. Scientists discovered an expected wave-like pattern with bright and dim strips by projecting light through a screen with two vertical slits cut out of it and onto a canvas behind it. However, it was impossible for it to exhibit wave-like behavior when they isolated the particles so that only one photon was allowed to travel through the slits at a time. But then the screen changed once more, and the light started behaving like a particle just as testers were about to set up a detector to truly see how this was happening. More generally, the cosmos behaves in one way, but as soon as we witness it, it alters in some way, making what we perceive to be a significant illusion. And if we were to examine the cosmos at the quantum level, this would be happening constantly. The usual laws of nature or even common sense would not apply if the quantum realm somehow found its way into our daily lives. Everything you could understand would continually be affected by your presence and point of view. It would be like having a slice of pizza with every possible topping at once, but when you decide you want pepperoni, it magically turns into pepperoni. The car would therefore exist as a cloud of possibility, simultaneously being in any location you could imagine and only picking where it actually was when you started looking. Or it would be as if you forgot where you parked your car. So, in the quantum realm, everything is constantly moving and only settles into place when observed. In fact, your own body would practically scatter over all of existence until you look down to see it, despite the fact that this is inconceivable in our current reality. But suppose you were a quantum particle. It's very likely, perhaps unavoidable, that you'd become entangled with someone else simply by brushing into each other, just as particles do. The actions of that second particle person would then affect your own experience, and decisions would be divided between the two of you. In practice, if you choose to ride your bike to work, your entangled partner would opt to drive. They'd stay up all night if you went to bed early. They would spin counterclockwise if you span clockwise. If you entered the quantum realm while remembering your previous life as a full-size person, life would be difficult, if not impossible, to adjust to. You may never be certain of anything, but you can be certain of everything, knowing that nature responds to your observations. Convince yourself that you have a puppy, and you may find one pawing at your feet. You will be able to walk through a wall if you believe you can. You may even be able to teleport. You, like all the particles surrounding you, now exist in every possible location at the same time. So, if you close your eyes and imagine yourself on a desert island, you might find yourself there. It'd be a one-of-a-kind, colorful, and never-ending mess stuffed with seemingly inconceivable events, to the point where you'd wonder what's real, or if real even exists anymore. That is exactly what would occur if you entered the quantum realm. In conclusion, venturing into the enigmatic quantum realm would present an extraordinary opportunity for unlocking immense knowledge, technological advancements, and deep philosophical insights. While the challenges are substantial, the potential rewards are equally transformative. Gradually demystifying the quantum realm would undoubtedly propel humanity toward a profound understanding of nature and fundamentally reshape the boundaries of our knowledge.